All right, here we begin. I'm in my backyard enjoying a little fireplace and a nice warmish spring evening, and we're going to do ourselves some rational equations. Rational equations. All right, so just a reminder that this is on page 156 of your student workbook, and I'm going to walk through it in slide format, do a couple of selected questions from the class examples just to give you my thoughts and get our head around some of the stuff we're doing. So we're going to beginning, as usual, we're going to start off with some simple warm-ups. This is just a straight up equation, something that you might likely have seen in grade 9, as a matter of fact. So we got 3 times the quantity of x minus 4 minus 10 equals 9 minus 5 times the quantity of x plus 3. And so obviously the first step we're going to do here is expand and distribute the 3 across the x minus 4, and expand and distribute the 5 over the x plus 3. Now, just a quick warning here: when you're distributing 5 across this bracket, you're distributing minus 5, so it's going to be minus 5x there, and then minus 3 times 15, 3 times 5, 15. All right, so that's something that even now folks make some simple basic errors with. All right, so I think the next step will be to bring all of the x's to one side and all the constants to the other. And we just do that by adding or subtracting whatever you need. See a minus 10 and a minus 12 over here. Well, we're simply going to add it. We're going to move it to the other side, and we will change the sign. Easy peasy. And now we'll gather like terms. I think we got 8x equals 16. And that simplifies to x equals 2. I don't see any non-permissible values because you don't have x in the denominator anywhere. And then if we're going to use set notation, because we kind of like set notation, there's your answer. Solution is 2. Cool. All right, next question right next door. X plus 6 over 4 plus 1 equals 5x minus 3 over 3. So the deal here is to convert every single term under a common denominator. Okay, now there's 2 ways to do it. I'm going to show you sort of the long form way that gives rise to a little shortcut later on. We're going to multiply each term by 1. So 3 over 3 is 1. 12 over 12 is 1. 4 over 4 is 1. As long as we multiply each term by something that equates to 1, we don't change the values. Now, what representation of 1 you choose depends on what you need to multiply the denominator by to get a lowest common denominator. And so when you multiply each term by its special fraction that equals 1, it's going to look like this, right? So 3 times x plus 6 is going to be 3x plus 18 over 3 times 4, 12. 1 times 12 over 12 is simply 12 over 12. And 4 times this mess is 20x minus 12 over 12, okay? So now you see we've got the lowest common denominator across each term. Cool. All right, so I'm going to show you a little trick here now that's going to make our life a little simpler moving forward. And it sort of explains, once again, we do these little tricks, but sometimes you don't understand why they work. Okay, this is why they work. It works because of this little explanation here. You have a fraction a over b, and it equals c over b. Well, then a equals c. Now, this is a very simplistic version of it, but if you have 1 over 2, and it equals 1 over 2, then the 1 over here equals the 1 over there. All right, they equal each other. So if you've got 2 rational expressions over the same denominator, then you can just equate the numerators. Now, how's that going to work in practice? Well, here's our expression that we have from the question. And you notice that they're all over the same denominator. That rule we just looked at says that we can just have to look at the numerators. So 3x plus 18 plus 12 is going to be equal to 20x minus 12. So the next step is to bring all the x's to one side and all the constants to the other. And I'm going to bring all the numbers to the left side. So 18 and 12 plus 12 is going to be 42. And when I bring the 3x over there, it's going to be 17. 42 equals 17x, or in other words, 17x equals 42. And the only fraction, the only simplification you can do is to say that x equals 42/17. That's not a very pretty fraction, but it is what it is. All right, next question. 10 plus 2 over x equals 8. Now that we have an x in the denominator, we are going to have to worry about something called non-permissible values. Values for x that may not equal, that make the expression blow up and become undefined. So without doing any more work, you can tell that if x equals 0, then you've got 2 over 0, and you've got an undefined term here. 10 plus an undefined term, doesn't matter. The whole equation blows up. So x may not be equal to 0. Remember that for the end when we tie this all together. Well, you can probably do this by inspection. 10 plus 2 over x, so 10 plus something equals 8, right? So by inspection, you know that this whole term here has to be -2, right? Because 10 plus -2 will equal 8. So the x to make 2 over x -2 has to be equal to -1. So there's your solution. So we can do this question by inspection. If you want to do it by algebra, go ahead. I challenge you. It's not a big deal, but it's just a little simplification we can do just right here. All right. We have m minus 3 over 2m plus m minus 1 over m equals 7/8. And so when you've got a situation like this, when you have rational terms throughout your equation, first thing you have to decide on is what is your common denominator going to be? Well, the common denominator is going to be common between 2m and 8. And so it looks like 8m will do it. I multiply this by 4, multiply this by 8, and multiply this by m, that should do. So we're going to multiply the first term by 4 over 4 using that long way, that long form way we started doing this work with. Multiply the second term by 8 over 8, and multiply double P, the last term, by m over m. Each one of these multiplications is really just multiplying by 1, isn't it? And so it's not going to change the value or the answer of the equation. So here's what we're going to get. There's the first term multiplied by 1. There's the second term multiplied by its version of 1. And finally, the last term multiplied by its version of 1. Let's distribute those multiplicans across. Good. So I've kept the 4 outside the m minus 3, but I've multiplied 4 times 2m to give us the 8m. And same thing here and here. And same thing here, 7m over 8m. Cool. Let's bring everything over. We can do 1 to 2 things now. And I can't remember what I did actually in my next slide. We can either bring it all together over a common denominator of 8m, or we can simply make the equation that 4 times m minus 3 plus 8 times m plus 1 equals 7m. Let's see what I did. Yep, that's what I did. I just took the numerators down because I know I can do that with the same denominators here. All right, so there's what we have. That's what we have from the last screen. Let's expand the 4m, 4 over the first set of terms and the 8 over the next. That's right, 4m minus 12 plus 8m minus 8 equals 7. Let's bring all the m's to the side and all the constants to the right side. Yep, that looks right. 5m equals 20, and then simplified m equals 4. Cool. And so there is our answer in set notation, but remember that m may not equal 0 because of the first version of the equation you had where you had m in the denominator. So your answer is a set of numbers that include number 4 with the non-permitted value of 0 for m. All right, let's work right through it. Here's the next question. What are we going to do? What are we going to do? Well, now we're going to do that special trick. The common denominator in this case will be x plus 6. So what I'm going to do is I'm going to multiply every single term by x plus 6. That's the shortcut of doing it the long way that we've been using for the last couple of times. So I'm going to multiply the whole mess. That's the bar notation I use, times x plus 6. Well, what are we going to get when we do that? Well, we're going to get x times x plus 6, excuse the extra parentheses here, plus 9, because 9 times x plus 6 over x plus 6 will allow the x plus 6's to divide out, and then we'll have 4 times x plus 6. All right, so let's expand. Let's distribute the x over x plus 6, and we're going to get an x squared term now, plus 6x plus 9, good, and 4x and 24. Let's bring all of the x terms and all of the constants on one side, give us a nice fat quadratic. There we go. X squared plus 2x minus 15. Now, can you recognize that, and can you factor that with integral factors? You sure can. And how did I get that so fast? Well, magic, right? Nah, this is weeks and weeks of me playing around with quadratics and learning to recognize things. Is this true? X times x, x squared, minus 3x plus 5x, there's plus 2x, and then 5 times negative 3. Yep, this is true. So here is your factored form of that quadratic. And so we're going to have two possible answers, I think, for this equation. Yep, x plus 5 equals 0, or x minus 3 equals 0. In other words, x is negative 5 or 3. And what about non-permitted values? Well, there aren't any in this case because you don't have x in a denominator, nor do you have x as a radicand. So you don't have to take the square root of something, and you don't have to divide it by 0. Moving right along. Now we've got something a little bit more interesting. We can use all of our skills to try to figure this out. Do you see what we're working with here? Do you see the beginnings of a common denominator? Well, if it was just these two terms, easy peasy. But do you see what this factors out as? Well, I'm going to tell you that the common denominator is y minus 3 times y minus 6, which means that we think there might be a y minus 3 and a y minus 6 hidden in there. And lo and behold, I believe there is. Yes, there is. So there's y squared minus 6y minus another 3y. There's minus 9y plus 3 times 6 is 18. Good. Now we have that common denominator of x minus 3 times y minus 3. And remember, this is that trick we're using. Okay, when we multiply by that lowest common denominator, this is, well, it works because multiplying by y minus 3 times y minus 6 is the same as multiplying by y minus 3 times y minus 6 over y minus 3 times y minus 6. You get the same result. That's the little trick about making the denominators the same and then just looking at the numerators. Go ahead, work it out. You can pause right here and make sure that this is true. So when we clear our fractions, we're left with 9 times the y minus 6, because the y minus 3 divide out, minus 4 times y over 3, y minus 3 because the y minus 6 divides out, and lonely 18 because both of these terms will divide out. Cool, let's expand and let's bring all of our common terms together. 5y is 60, y equals 12. Non-permitted values, yep, there's a couple, because you had the y minus 3 and a y minus 6 in the denominator. X may not equal to either of those. Y may not equal to 3 nor 6. There is your final answer. Cool. All right, and another question, a little bit tricky, but now it shouldn't be because you recognize some factoring that can go on right there. Well, we're going to factor the x out, and we get that. And we're also going to turn around the second set of terms here. Okay, the 1 minus 3, we're going to turn to minus x, or the 1 minus x, we're going to turn into minus x plus 1. Why are we going to do that? Because we want this term to look like this term. And so to do that now, we still have to divide out minus 1. All right? So take a look at that. Nothing has changed on the left side. It's just this last term here. We're dividing out negative 1. All right, now there's an x minus 1 here, and now we can suss out a common denominator of x times x minus 1. Cool. So let's Well, we can also declare our non-permitted values right now, right here and now. Because of this, x may not equal to 1. And because of this, x may not equal to 0. All right. So let's multiply now by the common denominator of x times x minus 1. And let's see what we get. All right. Well, the x times x minus 1 on the bottom, we're going to divide out on the first term. And we're going to get the full-on 5 times x minus 1 on the second term because the x's will divide out. And finally, the x minus 1 will divide out. And we will be left with 3x on the top and negative 1 on the bottom, right? Because we had that negative still we have to account for. Cool. All right. So that's what we have. Negative, or this whole mess, minus negative 3x over 1. Well, that's going to be turned into a positive. So we'll expand the brackets here. We'll distribute the 5, and we'll turn the plus, the minus into a plus. Cool. And now we'll gather up like terms. 8x equals 8. In other words, x equals 1. And remember our non-permitted values we declared right up front. But here's the kicker. Because x itself is a non-permitted value, there's only one answer here. X is 1. If the answer you get is not permitted, because it would make the full equation blow up because of the divide by 0 error. That is, if the only answer is not permitted, well, it turns out there is no answer. And the solution is an empty set. It's a null set. And you describe it like that. So there is no solution to this particular question. We call this an extraneous answer. It looks like it's an answer, but it is not permitted because of the divide by 0 restriction from the original equation. All right, there we go. We are done. You are ready to go and play with a whole bunch of rational expressions on the following pages. Go out there, math your little hearts out, and I will enjoy the last little bit of my campfire.